72 degrees below zero. At this temperature, metal shatters like glass. Trees explode from the inside out as their sap freezes. Your breath crystallizes midair, falling to the ground with a sound like breaking icicles. An exposed skin freezes in under a minute. This is not theoretical cold. This is not the cold of adventure stories. This is the reality of winter in the Yakutsian wilderness of Siberia. And in this realm of impossible cold, humans have survived, and not for years, not for decades, but for centuries. Without electricity, without modern insulation, without the technological barricades we assume necessary for life. And most remarkably, they solved the most fundamental problem of survival: finding and maintaining liquid water when the world around you has transformed into an unforgiving solid. If this kind of ancestral survival knowledge interests you, subscribe. Let's keep going. What I'm about to describe isn't a historical curiosity or a primitive method we've outgrown. It's something more profound, a counterintuitive truth about human adaptation. While we imagine technological progress as a straight line forward, the Yakut people of northeastern Siberia have maintained knowledge that reflects something deeper. Perfect adaptation doesn't always mean complexity. Sometimes it means entering into a relationship with extreme conditions rather than fighting against them. And nowhere is this more evident than in how they've solved the seemingly impossible challenge of maintaining drinking water in the coldest inhabited place on Earth. The Yakuts, or Saka people as they call themselves, live in a region where winter temperatures regularly plunge below -60 degrees Fahrenheit and have been recorded as low as -96 degrees Fahrenheit. For context, at these temperatures, conventional modern water infrastructure fails catastrophically. Metal pipes crack, pumps seize, plastic becomes brittle and shatters. Even our most sophisticated modern solutions require enormous energy inputs to prevent freezing. And yet, for generations before the arrival of modern technology, the Yakut people maintained reliable access to drinking water through the darkest, coldest months of winter. Often was nothing more than carved wood, animal fat, and an intricate understanding of thermodynamics that predates the formal science by centuries. Their methods begin with a profound awareness of water's physical properties near its freezing point. Unlike many substances, water achieves its maximum density at about 39 degrees Fahrenheit, 4 degrees Celsius, slightly above its freezing point. This creates a critical phenomenon in deep bodies of water. As surface water cools below this temperature, it becomes less dense and remains on top, eventually forming ice, while the slightly warmer, denser water sinks to the bottom. This inverse relationship creates a natural stratification in lakes and rivers, where even when the surface is frozen solid, liquid water remains below. The Yakuts' first principle of winter water collection leverages this natural phenomenon. They identify specific locations on rivers and lakes where the ice forms thinnest due to underlying currents or thermal springs. These spots become designated water collection points for entire communities. Rather than fighting the ice, they work with it, maintaining specific access points where the labor of breaking through remains manageable even in the deepest cold. But identifying these locations isn't a matter of chance. It represents generations of careful observation passed through oral tradition. Yakut elders can read subtle signs in summer vegetation, shoreline formations, and even the behavior of animals to identify where winter water will remain most accessible. These spots become so valuable that traditional Yakut settlements often formed around them, with spatial organization of the community determined by proximity to these reliable winter water sources. Once a water access point is established, the Yakuts employ another counterintuitive technique. They deliberately allow a controlled ice layer to form, rather than trying to prevent freezing entirely. This seemingly paradoxical approach reveals their sophisticated understanding of ice as insulation. By maintaining a stable ice layer of specific thickness, they create a natural barrier that actually prevents deeper freezing. The ice becomes a protective lid, trapping the latent heat of the liquid water below and slowing further heat loss to the brutal air temperatures above. To maintain these ice-capped water access points, the Yakuts developed specialized tools that reflect their deep material understanding. The primary implement is the muozani, a specialized ice chisel made traditionally from birch wood with a sharpened bone or iron tip. Unlike modern metal tools that become dangerously cold and brittle in extreme temperatures, These composite tools maintain their integrity and remain safe to handle without transferring the killing cold to human hands. The design of these tools reveals another layer of sophisticated engineering. The chisel's wooden shaft incorporates subtle flexibility, allowing it to absorb the shock of striking dense ice without shattering or transferring destructive vibration to the user's joints. The striking head is carefully weighted to maximize impact force while minimizing the physical exertion required, a critical consideration when every calorie of energy counts in the extreme cold. The technique for actually breaking through the ice reveals yet another dimension of accumulated wisdom. Rather than applying brute force, Yakut ice harvesters use a methodical, almost rhythmic approach, creating a pattern of precisely spaced strikes that propagate cracks through the ice's crystalline structure. This technique exploits the natural fracture planes within the ice, requiring far less physical exertion than trying to power through by force alone. The result is a clean, minimally sized opening that can be easily maintained and quickly resealed to prevent excessive heat loss from the water below. Once the water access hole is created, maintaining it becomes a community responsibility. Each family assigned to water collection takes precise measures to ensure the opening doesn't freeze completely between uses. This is where another ingenious adaptation comes into play: the creation of a microclimate around the water access point. The Yakuts construct a miniature shelter directly over the ice hole. Traditionally a small dome-shaped structure made from bent saplings covered with animal hides. This creates a protected pocket of air then, while still well below freezing by most standards, remains significantly warmer than the external environment. Inside this shelter, the water hole is covered with layers of insulative material between uses, often a combination of woven horsehair, dried grasses, and sometimes animal skins with the fur side facing downward. These materials are chosen for specific physical properties. Horsehair, for instance, maintains its insulative abilities even when partially damp, while certain dried grasses contain natural oils that repel water and prevent the insulation from becoming waterlogged. Most critically, these natural materials don't become brittle and useless in extreme cold the way many modern synthetic insulators would. The sophistication continues in how water is actually transported from these access points to dwellings. The Yakuts traditionally used specialized water carriers carved from a single piece of larchwood. Unlike metal or ceramic containers that would rapidly conduct heat away from the water, wood provides natural insulation. But the design goes further. These containers would be seasoned by repeatedly coating the interior with animal fat and heating it until the fat penetrated the wood fibers. This created a naturally hydrophobic inner surface that prevented water from saturating and potentially freezing inside the wood itself. The transportation of water requires its own set of carefully developed techniques. When moving water in temperatures below -60 degrees Fahrenheit, the margin between liquid and solid is measured in minutes, sometimes seconds. Yakut water carriers would wrap their containers in layers of fur and felt, creating a portable insulation system. But perhaps most tellingly, the routes between water sources and dwellings were precisely planned and maintained. Pads would be packed down to minimize physical exertion, and in the most organized settlements, would be partially sheltered with wind barriers made from packed snow or strategically placed brush. Inside the traditional Yakut dwelling, or Balagan, water storage reflects another layer of environmental adaptation. These semi-subterranean homes were constructed with double-wall insulation filled with dried grass, moss, and animal hair. Inside, they maintained a careful temperature gradient, with the warmest area concentrated around the central hearth. Water was stored in wooden casks positioned at specific distances from this heat source, close enough to prevent freezing, but not so close as to promote bacterial growth or require excessive fuel to maintain. The Balagan's design incorporated sophisticated passive ventilation that maintained air quality while minimizing heat loss. Small, carefully positioned vents created a natural convection current that drew fresh air in at floor level while allowing the more humid, used air to escape near the ceiling. This circulation prevented the dangerous condensation that would otherwise form on interior surfaces in such cold environments, where any accumulated moisture would become a deadly conductor of cold. The traditional Yakut understanding of water extended beyond mere physical management to include a complex knowledge of water quality and safety. Without modern purification methods, they developed observable indicators for water purity. Certain aquatic plants growing in summer would mark water sources known to remain clean and free from harmful minerals. They understood that not all winter water sources were equal. Some would contain higher concentrations of minerals or organic material that made them unsuitable for drinking but perfectly adequate for other uses. This stratified usage system, designating different water sources for drinking, cooking, cleaning, and animal husbandry, represents a sophisticated resource management approach that maximizes the benefit from each water source while minimizing the extremely energy-intensive process of harvesting and transporting water in deadly conditions. Perhaps most remarkable is how this traditional knowledge integrated with spiritual and community practices. The responsibility for maintaining water access was shared according to complex social structures that ensured no single family bore too much of the physical burden, while also maintaining necessary expertise across multiple households. Water collection became incorporated into coming-of-age rituals and social hierarchies that reinforced both the practical techniques and their cultural importance. Water sources themselves held spiritual significance, with specific taboos and observances surrounding their use. While easy to dismiss as mere superstition, many of these practices served crucial practical functions. Prohibitions against certain activities near water sources protected water quality. Rituals of offering and respect ensured that water holes were properly maintained and covered. The spiritual framework provided the social reinforcement necessary to maintain these life-preserving practices across generations. As modern infrastructure has gradually reached even the most remote Yakut communities, some of these traditional practices have declined. Yet recent extreme weather events and infrastructure failures have highlighted the resilience of traditional approaches. During power outages and mechanical failures that have immobilized modern water systems, communities have returned to traditional ice hole management and water collection methods, often led by elders who maintained this knowledge despite decades of availability of piped water. This intersection of ancient practice with modern crisis reveals something profound about technological resilience. The most sophisticated modern systems often incorporate single points of failure, a power grid, specialized parts, complex pumps that, when compromised, fail completely. Traditional Yakut water management, in contrast, builds redundancy through simplicity and distributed knowledge. When one water access point becomes unusable, the knowledge to establish another remains widespread within the community. This principle extends beyond water to the entire Yakut approach to extreme cold survival. Their traditional clothing system, for instance, uses multiple adaptable layers of fur and leather that can be adjusted based on activity levels and changing conditions. This stands in stark contrast to modern extreme weather gear that, while highly effective when functioning perfectly, offers little adaptability when damaged or in conditions beyond its design parameters. The traditional Yakut diet similarly reflects this resilient adaptability. Heavy in animal fats and proteins, it provides the caloric density needed to maintain body heat in extreme conditions. More importantly, their food preservation techniques, primarily using the natural refrigeration of the permafrost combined with specific fermentation and drying methods, require no external energy inputs to maintain. This creates a food security system impervious to the infrastructure failures that would render modern refrigeration useless. Even their approach to fire and heating demonstrates this principle. The traditional Yakut stove design maximizes heat retention, while minimizing fuel consumption through a carefully engineered system of heat baffles that extract nearly every calorie of warmth from burning wood before the smoke exits. This efficiency wasn't a luxury but a necessity in an environment where suitable firewood might be scarce and the consequences of inadequate heating immediately fatal. What emerges from studying these interconnected systems is a profound recognition. The Yakuts didn't merely survive in one of Earth's most hostile environments. They developed a regenerative relationship with it. Their techniques didn't fight against the fundamental nature of cold and ice, but worked within its constraints to create sustainable human habitation. This stands in sharp contrast to many modern approaches that consume enormous resources to maintain artificial environments completely divorced from external conditions. The deeper lesson here extends beyond survival techniques to something more fundamental about human adaptation and technology. The most durable solutions often arise not from imposing our will upon the environment, but from aligning our needs with the inherent properties of the world around us. The sophisticated simplicity of Yakut water management represents not a primitive approach we've outgrown, but potentially a model we may need to remember as we face increasing climatic instability and resource constraints. In many ways, the true mastery of the Yakut approach to extreme cold wasn't technological but philosophical. The recognition that survival comes not from separation from the natural world but from deeper integration with it. Their water management system worked because it accepted and utilized the properties of cold and ice rather than solely attempting to defeat them. This philosophical framework created not only physical survival but cultural continuity in conditions that most modern humans would consider uninhabitable. As our own infrastructure faces increasing pressure from climatic extremes, the Yakut relationship with cold offers something beyond mere historical interest. It provides a conceptual model for resilience based not on resource-intensive resistance to environmental conditions, but on adaptive integration with them. This isn't to suggest we should abandon modern technology, but rather that we might design more resilient systems by incorporating the philosophical approaches that allowed the Yakuts to maintain water and life itself in conditions that still challenge our most advanced engineering. The next time you turn a tap and water flows effortlessly regardless of the temperature outside, remember the Yakut ice harvesters. Their knowledge represents not just a fascinating anthropological curiosity, but a testament to human adaptability and a potential source of wisdom for navigating our own uncertain climatic future. Their relationship with water and impossible cold reminds us that sometimes the most sophisticated technology isn't what we build to conquer nature, but what we learn by aligning ourselves with it. If this exploration of traditional survival wisdom resonated with you, consider sharing it with someone who appreciates the deeper intelligence behind ancestral practices. These aren't just stories from the past. They're potential blueprints for resilience in an increasingly unpredictable world. What other ancient solutions might hold answers to modern problems? I'd be curious to hear your thoughts in the comments below.